I think after today, you might want to insult me because we have got some fun stuff to do. And from one of my favorite movies, you use that word a lot, but I do not think it means what you think it means. So when I say you're going to have a lot of fun today, it may or may not be true. We are going to be working on section 7.2. We are going to be doing what's called the addition and subtraction formulas. So we are going to use one of these 6 guys to help us find exact values for trig functions, or for trig angles, I should say, that are not in the unit circle. See, I know what the exact value for the sine, the cosine, and the tan of 45 degrees is, right? Unit circle will tell me that. But I'd like to know the exact value for other angles that are not on the unit circle. So here's a little baby version of in degrees, because I think degrees are easier to work with. An example of the guys that we already know the exact values of. So what happens in the addition and subtraction formula, one of the main types of questions you get would be something like question 1, where we are going to find, and the key word here is exact value. We're going to find the exact value of an angle that is not in the unit circle. Yeah. So, right, there is no 75 degrees on a unit circle. Now, could I get the value? Well, I could put it in my calculator, but wouldn't that just give me a decimal approximation? So how do we get an exact value? We use one of these guys. So start off with, I know it's the cosine that I'm dealing with. So the only 2 guys I need to worry about are number 3 and number 4. Now, what these equations do is they tell you that if you want to find the sine of an angle A plus an angle B, you can actually get that answer by multiplying the sine of A times the cosine of B, and then add the cosine of A times the sine of B. So basically, these 6 guys, you want to write them down somewhere eventually, right, and just have them on hand when you need them. For instance, I'm now on cosines, right, 75. So I'm going to either use this addition formula because you're adding 2 angles, or this subtraction formula because I'm subtracting 2. And you might say, well, how do I figure out what to do? I mean, very often you can use either. I like addition. I don't know, my brain seems to work better with addition. You need to find 2 angles that are on the unit circle. So you can only use these numbers in red. And you need 2 of them that add up and give you 75. Or you need to find 2 of them. If you take one and subtract the other, you get 75. It doesn't matter what you do, right? If you can find one that adds, use it. If you can find one that subtracts, use it. You end up with the right answer both ways. Can anybody see a combination that would get me 75?
30 and 45.
That's what my brain is telling me. I wonder if there's a subtraction. Oh, there should be. If I try hard enough, I might be able to get one. Got one. Can anybody tell me, just because they can you find 2 guys subtracted?
120 and 45.
120, yes, and 45? I think that's what you said. Yeah, okay. Yeah. So it doesn't matter which one. I like adding. I don't know, my brain just works better. I can think of 2 things added that equals 75 easier than I can think of 2 things subtracted. So pick whatever your poison is. I'm going to return back to this one because I like it. So once you've identified a combination of 2 added or 2 guys subtracted that equals 75, in this case, this one, that guy's my A and that's my plus B. So I find the formula. And so in my case, wouldn't that be formula number 3? And it's the cosine of A, the cosine of B, oops, got that one wrong. Take away the sine of A, the sine of B. Sorry about the mess. Right. So it's going to be the cosine of 30 degrees and the cosine of 45 degrees. Take away the sine of 30 degrees and the sine of 45 degrees. So you're going to have your unit circle as well. So here it goes. Cosine of 30, right? There's 30 degrees. The cosine is the x coordinate, so that's √3 upon 2. The cosine of 45 degrees is √2 over 2. Take away the sine of 30 degrees is a half, and the sine of 45 is √2 over 2. That guy gets you √6 over 4. That guy gets you take away √2 over 4. And the whole thing, when you combine them into a single fraction, gets you that. And you can't do anything else. So you're not allowed to subtract 2 square roots, right? So the square root of 6, take away the square root of 2 is not the square root of 4, right? That doesn't work. So you're finished. Might look kind of ugly, but there is now the exact value for the cosine of 75. So we're able to, using this technique of addition and subtraction formula, we're now able to increase the number of angles that we can find exact values for. Do you like it? Now, I'm not doing that one, but can you trust me, if you did this one, you get the exact same answer, right? You can check it yourself later. So it's all about finding 2 angles that add up or subtract. In this case.
Can you go back to that last one?
So 2 angles that add or subtract to give me 225. I'll wait a few moments. Are we good on this? Not yet. Okay.
How come you went from a positive to a negative when you went from cosine A minus cosine B when the original formula is 30 plus 45?
The formula that allows you to do a cosine of A plus B, which is what I'm doing here, has a negative in it. So when you're adding 2 things, this is subtraction. And when you subtract 2, this is an addition. So it's in the formula. Okay. Right, 225 degrees. Give me 2 guys that add or 2 guys that subtract that come to 225 degrees. Here's your choices. Two guys added or 2 guys subtracted. Oh, nobody got a... Can you just pick one at random and see what you need to add to get 225? And if the second one is in the thing, you've got one, right?
Could you do 315 minus 90?
315, which is okay. Take away how much again?
90?
Cool, right?
Mm-hmm.
So you're off the list. Yes. Give me another one. Somebody else.
That's 315 minus 90, not plus 90.
Oh yeah, my apologies. Right, give me another one. I keep wanting to add things. That's probably why I keep putting pluses down. Come on.
135 plus 90.
One last one. I'm sure there's a lot more, but one last one. Nobody got one?
45 plus 80.
45 degree plus 180. That works. Okay, it doesn't matter which one of those three we pick, right? Because if you get one that works, you're going to get the right answer. Let's do the subtraction one. So the sine of 225 degrees is going to be the sine of 315 degrees take away 90 degrees. So that's essentially going to be the sine of A take away B, right? So the sine of A take away B has two guys take away two other guys. And in this particular one, A is going to be this fella, B is going to be that one. So it's going to be the sine of A cosine of B, take away cosine of A, sine of B, and then we'll put in all the numbers for them. So it's going to be the sine of 315 degrees with the cosine of 90, take away the cosine of 315 degrees times the sine of 90. And then I kind of need this fella. So here it goes. 315 degrees, the sine is negative 2 over 2. 90 degrees, the cosine is 0. So you multiply those two together. Take away the cosine of 315 degrees is positive root 2 over 2 times the sine of 90 degrees, which is 1. And that guy ends up being negative root 2 over 2. That's interesting. Oh, of course, 225 degrees is actually on the unit circle. Hey, but it worked, right? It just shows you it works even if it's not in the unit circle. Yeah. I should have probably seen that as a shortcut.
Okay, no, I was gonna ask about that on if we had a sine of 225, do we have
Yeah,
to
you
do
would
the
just
addition
take
and
the answer
subtraction?
straight off the table, wouldn't you?
Okay.
Right? You
Yeah.
make your life 10 times easier. But I mean, it does kind of prove, doesn't it, that this method works, right? It did actually get you an answer. Let's find another guy then. They seem to like 5s for some reason. Let's do a version of 3. Oh, good, a tangent. 165 degrees. Okay. Here's my little baby circle with just the degrees in it. I need some help here. 2 guys added 165. 2 guys subtracted 165. Don't care which, just find somebody.
120 plus 45.
What was going on in your head there for those people who are taking a bit longer? How do you figure that one out, Cassandra?
Just 2 numbers on the unit circle that add up.
They just came to your brain, you just looked and boom, they bounced out at you.
Yeah.
Okay, sure that's what happened. You know, your brain's a complex thing. Don't you sometimes know the answer without knowing how you got the answer? It just comes to you, right? And sometimes that's what's happening. If you need a strategy, couldn't you just randomly pick a number, right? So let's suppose I picked 120, just for randomness, right? All I'd say is, okay, what more do I need? Oh, I need another 45. Is that in the unit circle? Yes, I could use it, right? Now, what happens if I started with 135, right? That's another random choice. What would I need to get 165? Right, so 135 plus what would get me to 165?
30.
Right, so I couldn't use that one then, couldn't I?
Mm-hmm.
Right, obviously you can't use numbers that are too big, but you could use, you know, numbers over here, right? Suppose I pick 60, just for argument's sake. Wouldn't I need 105? But you see that one doesn't work, right? Because I don't have 105. So you could basically just pick somebody and see, what do you need? And if what you need's on the unit circle, you've got an answer. If it's not, well, pick somebody else and try again. Pick somebody else. Won't you eventually get somebody somewhere that'll work? Now, this is basically the tangent of A plus B. And so my formula for the tangent of A plus B is this guy here. So it's going to be the tangent of A plus the tangent of B all over 1 take away the 2 things multiplied. So the tangent of 120 plus the tangent of 45 degrees, 1 take away the tangent of 120 times the tangent of 45 degrees. Unit circle now. 120 degrees is here, right? And the tangent is basically that guy divided by that. You know the shortcut, you can just pretend the bottoms aren't there, right? So root 3 on the top over -1, that guy is negative root 3. Add 45 degrees. Well, there's 45 degrees. Isn't y over x just 1? 1 take away that guy times that guy. And so the top row ends up looking like that, and the bottom row ends up looking like that. And don't try and make it look pretty, because you're probably not going to be able to easily. Are we good? Right, so you can find the sine, cosine, or tangent of other angles now by using the addition and or subtraction formulas. What can they do to make your life a little bit more difficult? Well, they could make it radians. They could make it negative, right? Let's do a negative first, and then we'll do a radian. I need 2 guys added or subtracted. Chances are it's going to be subtracted. Would you agree? Because the answer's negative, right? That give me negative 15 as the answer. Now, since I know the answer is negative, doesn't that tell me little guy take away bigger guy, right? So here's your choices.
30 minus 45.
Agreed. If you go hunting, can you trust me? There's quite a few answers at work, but we don't care. We only need to find one, right? You find one, stop looking. So this guy is going to be the cosine of A take away B. And the reason I'm writing that down is just so that you get familiar with which one of the 6 formulas is the one for your situation, right? That's a A take away B situation. So it means this one is the one I'm going to use. So cosine of negative 15 degrees is going to be made from a cosine cosine plus a sine sine. And A is 30 degrees, so it's going to be a cosine of 30 degrees with a cosine of 45 degrees. Have you noticed that 45 seems to be around a lot? It's a very common combination to use. And so it's a sine of 30 degrees, cosine 45 degrees. Okay, unit circle, 30 degrees, the cosine is root 3 upon 2. Cosine of 45 is root 2 upon 2. Sine of 30 is a half. And this guy here is also root 2 upon 2. 2 guys at the top over 4, which is actually, by coincidence, one of the earlier answers. So can you use this technique to get negative, 85 degrees, right? Negative whatever, right? Things like that. So far, so good. Right. So if I gave you an angle, sine, cosine, or tangent of some number that was not on the unit circle, do you feel comfortable about figuring out two guys that add or subtract that equal this? Find out which of the 6 formulas is the right one to use based on your combination.
When using a negative angle and working with tangent, would you use the first quadrant and just make it negative?
Oh, you could. I wouldn't do that. Me personally, I think that works fine, but I don't want to add any more layers of complexity that don't need it. But yeah, if you find that makes your life a little bit easier, you could. Because you know from which quadrant it's in, whether it's plus or minus, you can tweak it a little bit. The way I'm showing you is basically it doesn't care what quadrant it's in, right? You know, it works, and that makes life just a tad simpler. That's the only reason I choose.
I have a question.
Yes.
So what if the angle doesn't end in a 0 or 5? So it's like, say it's like 134 degrees.
And the good news is there is no way to do it, and therefore the question doesn't exist. Right. So this method doesn't work for every angle in the universe, right? 72 degrees is not going to work with this method, right? Because your building blocks are quite limited, aren't your building block only these numbers? And there's only so many things you can get. Would you agree if you add and subtract any of these numbers, isn't your answer going to end in a 5 or a 0? Right. So you can't use this technique to do 72 degrees or 41 degrees or other ones. So question is irrelevant because it's impossible to get an answer. Are we cool? Now, that's all the degree combinations done as far as I'm concerned. Let's do and I'll rewrite that again because it looks like a 6. How do you get things like 5, 6 pi? Now, if I put this guy here, would you agree that 5/12, I should say, pi, is not in the unit circle? Now, you could actually just try and find combinations of these guys, added and subtracted, and make the thing work. But they're not really designed well for playing well together. Would you agree that 11/6 pi, add or subtract 7/4 pi, it's not at all obvious what the heck that is even equal to? Would you agree? So radians don't really play well with this method. So since I don't want to make my life difficult, what I'm going to do is turn this guy into degrees so I can use a method that I am comfortable with. So, okay, so we've got an extra step here. Can anybody remember the formula for turning radians into degrees? Something over something times something.
Your radian times 180 divided by pi.
Okay. There's the radians over, oops, times 180 over pi. And don't they cancel out? Right, the pi's disappear. And you basically just find 5/12. And I've lost my, oh, there it is. So I go to the calculator and I go, okay, there's 5/12. Oops, do that again. There's 5/12, times it by 180. And now my question becomes, the sine of 75 degrees. Isn't the sine of 75 degrees much easier to do? I won't take this question the whole way. What combination from this list, add or subtract, gets you 75?
30 and 45.
Right, 30 and 45 is. Wouldn't that be the number one formula? And off you go and get your answer. How about the tangent of it's so hard to make ones up. They don't have many, at least of the type I want. I have to do a 12th. It's only all I've got. Okay. I'll pick the ugliest one I can think of. Right. I want to find the exact value of negative 7/12 pi. So I would start by turning it into degrees. So it would be negative 7/12 pi divided by pi times 180. The pi's cancel out, so I'm just basically going to do 7/12 times 180, and the answer I get is negative 105. Okay, I need two guys subtracted this time because it's a negative answer. Right, little guy take away big guy, that gives me negative 105. What would that
45
be?
minus 150.
You all comfortable with that one? So that would turn into, I'll just put the original down here. Right. So that would turn into a tan of A minus B. And that would be number 6 in my list. So the answer will be the tan of A, take away the tan of B, all over 1, take away those two guys multiplied.
So in this case, could we do, instead of the tan of a number minus a number, could we do the negative tangent of 60 plus 45?
I'm trying to do that in my head. Yes. So
And
we
isn't the
have,
formula 1 plus tan AB on the bottom?
thank you. So tan of 45 degrees, take away tan of 150. 1 add tan of 45 degrees, tan of 150. Okay, tan of 45, I'll need my unit circle, but I know that's 1. But here we go. Y over X, that's 1. Take away tan of 150, here's tan of 150. If you take the Y and divide it by the X, you get a rather ugly negative 1 over root 3. Then you have 1 plus that guy times that guy. I'm actually, now that I've seen that, I'm kind of glad I did this one, because there is some style points that we can do. Right. That's what the answer looks like, right? 1 plus this ugly fraction, 1 because of this guy here. Take away that ugly fraction. By the way, it's a weird looking 1 there. We don't like fractions with fractions in them. And the algebra trick to do that is by multiplying the top and bottom by the same number. Essentially, you're multiplying by 1. And the version I'm going to do is that version of 1. So top guy, 1 times root 3. This guy times this guy gets you 1. This guy times this guy gets you root 3. And this guy times this guy gets you -1. Would you agree that's a little bit prettier looking? So that was the original. This is the pretty version, style points.
Are you saying style points or style
Yes,
points?
I'm staying S-T-Y-L-E.
This
Style
whole
points.
quarter, I thought you were calling them stale points.
Oh no, that's a horrible name. Right?
Okay.
You get points for looking nice, right? That equation has style to it.
I was thinking about it yesterday and it finally clicked that you were saying style points.
Yeah. And by the way, you won't find that anywhere. That's my name for it, right? I think if you look it up, it'll be called Simplify or something boring. But isn't style points a nicer name, right? You try to make it look pretty, right? Give it a bit of style, make it look good. So that's what we're doing. So what's next in this group of questions? Well, for want of a better word, I'm going to call them puzzle questions. So here's an example of a puzzle question. The cosine of 50 degrees times the cosine of 40 degrees. Take away the sine of 50 degrees times the sine of 40 degrees. And we're being asked to find, using the addition or subtraction formula, here's a keyword again, the exact value of this expression. Now, you might make your life a lot more difficult than it needs to be by thinking, oh yeah, I'm going to have to find the exact value of this guy, the exact value of this guy, then that guy, and then that guy. And then when I multiply them all together, that's what he's wanting, right? That's what the question's about. That is not actually how we're going to do this one, right? We're going to think smarter, right? If you look really carefully at this expression, doesn't it kind of look like one of these guys?
Isn't it cosine A plus B?
And let's see. A cosine and a cosine, take away a sine and a sine. Don't they look like the A's, right? And wouldn't you agree they're the B's? So if that is him, then shouldn't it equal cosine of A plus B? So that makes it, oops, put the cosine in, A plus B, which makes it the cosine of 90 degrees. And we all know that the cosine of 90 degrees is 0. Sneaky. So that expression, even although it's made up of bits we don't know the exact value of, by using this formula here, kind of going in that direction, can't we find out that this is equal to the cosine of 2 guys added? The 2 guys are added is a nice answer. We get the answer in that on the unit circle. Good. Oops. Wish I did another one of these. I don't know if I do. No, well. It was a nice question, but they're only one of them. Pity. So let's do an identity question. Right, we did them yesterday. The cosine of x take away pi upon 3, subtract the sine of x add pi upon 6 is equal to 0. And our job is to prove that. I have to prove that this guy, take away that guy, is 0. And we're going to use the addition and subtraction formula to help us. So if you think of this as being A take away B, right? then what you're going to get is the cosine of A cosine of B plus sine of A sine of B, because when you do a cosine of two things subtracted, you add the bits, and this becomes the cosine of x times the cosine of pi upon 3 plus the sine of x times the sine of pi upon 3. Are you comfortable with this, calling this guy A and calling this guy B, and using this formula here for the cosine of A take away B? We get that. And these guys here are, we can get their values. They're on the unit circle. Let's see what we have. If you do pi upon 3, it's this guy, and the cosine is a half. So that's cosine of x times a half, plus the sine of x. And if you find the sine of this guy, it's a little bit uglier, it's root 3 upon 2. So what do we get? We got a half cosine x plus root 3 upon 2 sine x. Then we're going to do a takeaway. This fella is like the sine of A plus B, right? And the sine of A plus B is the top one. And so this is going to be sine of A cosine of B plus cosine of A sine of B. That's going to be the sine of x times the cosine of pi upon 6 plus the cosine of x times the sine of pi upon 6. Cosine of pi upon 6. Here's our guy. Cosine of pi upon 6 is root 3 upon 2. Plus the cosine of x times the sine of pi upon 6, which is a half. And so you get root 3 upon 2 sine x plus 1/2 cosine x. Still with me, guys? Lots of bits to this. Does something really nice happen here? Won't that guy get killed off by that one? And won't this guy get killed off by that one? Agreed? So what is left? Exactly what should be left, right? 0. Any questions? So these addition subtraction formulas can be used to find the exact value of angles that are not in the unit circle. That was the first part of the day. You could use it to find the exact value of weird expressions, like question 5. And you can also use it to prove identities. So let's do another identity, probably the last one for today, we'll see. Question 9 asks us to prove that the sine of x take away y minus the sine of x plus y all over the cosine of x plus y plus the cosine of x minus y, that whole expression ends up being the same thing as negative the tan of y. Right, if we get that to happen, that's going to be pretty amazing, isn't it? I mean, look at how ugly that is, and look at what it looks like. And for Cassandra, look at its style points. You see that? Right. You wouldn't take this mess out, but that one's pretty cool, right? You might take him out. So each of these pieces is going to come from here. I just have to think of the x as being the A and the y as being the b. So I'm going to write above each one of them which one of these 6 equations I'm using. So this one here is going to use the second equation. This one's going to use the first equation. This one here is going to use the third equation, and this one here is going to use the fourth equation. So you see, we get to use almost all these equations just in this one question. So the sine of x minus y, that's this guy, is going to be the sine of x cosine of y subtract cosine of x sine of y. Okay, that's that guy. Take away, put a big bracket around it for safety. So I'm going to take away all of this, and that's going to be the sine of x cosine of y plus cosine of x sine of y. That's the top part done. Number 3 is this fella. So it's going to be cosine x cosine y take away sine x sine y. Add this fella here is cosine x cosine y plus sine x sine y. Well, I'll try and save a line of working by not writing all of that out again. Sine x cosine y, take away sine x cosine y. That guy gets killed off by that guy. This fella is negative, so is this guy negative, so you're going to have negative 2 of them. So that's what you get. 2 guys cancel, 2 guys combine. Now that guy and that guy are the same, and you're adding them, so you're going to get 2 of them. Positive this time. And that negative guy kills off that positive guy. So that's all that's left there. Okay, so the original turned into this ugly guy. Fair amount of tidying up and cancelling, which is nice. Now, can you tell me what we could do to make this pretty? What could we do to this fraction to make it pretty? Can you cancel anything? Is there something on the top that might cancel something on the bottom?
Combine the 2 cosines on the bottom now.
Anything else we could cancel that?
Oh, that's not what I meant. That works out.
Can't you cancel out 2's as well?
Yeah. And if you do that, aren't you just left with a negative sine y over cosine y? Wait a minute. Isn't that guy a tangent? We're finished.